All right, well, we are here with Ralph Ewig with Aerojet. Thank you very much for sitting down with us today.
Thank you, my pleasure.
Well, first of all, I'd like to ask you how it is that you got started in the space industry and how you ended up at Aerojet.
Okay, it's an interesting question, actually. My pathway's been pretty convoluted. I started out, actually, I was born in Germany, in Europe, and I went to study physics over there for a while, and then transitioned to the University of Washington in Seattle, and got all three of my degrees over there, bachelor's, a master's, PhD, all in aeronautics and astronautics, which was a great experience, and then kind of got stuck and decided to stay. And my first job was with NewSpace, which is a small company out of Seattle, and fairly entrepreneurial. I was their third employee, I believe. Did a lot of launch vehicle design analysis, performance analysis kind of things over there. And then from there spun off to form my own company together with two other people, Livingston Holder and Curtis Gifford. And we formed a company called Holder Aerospace. And it was a consulting company, and it was a great experience in terms of getting to know all the other different companies, because we worked for Boeing or for Lockheed, and a lot of the smaller guys like X-Core and Scale Composites and so forth. And then eventually met Gary Hudson and started working for him on their air launch. And that was a small company out of Kirkland, Washington, but also having test facilities out in Mojave in the mecca of NewSpace. And worked on a two-stage orbit launch vehicle for the Air Force under his guidance. And then when Air Launch shut its doors, my next stop was SpaceX. And I became a mission operations engineer at SpaceX, which was definitely one of the highlights of my career. I was responsible for integration of the Dragon spacecraft, final integration before launch for both communications and propulsion systems. And also worked in the control room during flight as a communications coordinator. So you got to talk with astronauts on the space station in real time and participate in the first docking of Dragon on the space station, which was fantastic. So.
Wow.
And then following SpaceX, I left there only about 6 months ago now, and joined Aerojet. And Aerojet made me an offer to become their VP of engineering. So I have a very large group of engineers under me, about 400, 450 people right now. And I'm responsible there for all the engineering activities across the entire portfolio of things that they do, which is quite a lot.
Wow. What projects or developments I guess, are your most favorite to be able to work on and manage?
Well, Aerojet does a lot of things. I was actually really surprised when I arrived there. I think the biggest transition for me was that I came from smaller companies or companies who were very focused on just doing one thing. And Aerojet is a large company which does a lot of different things at the same time. So it was a challenge for me at first to get my head around that and manage all of these and keep track of everything that's going on. But ultimately my first love still is space travel and human space travel specifically. So of course my favorite projects at Aerojet center around space and some of the things we support. Before I was there, Aerojet built the engines for the Curiosity Mars landing rover. That was a big one. We still build the solid rocket boosters on Atlas. We support Sierra Nevada corporations on their Dream Chaser project. We are also looking at we are supporting Orbital Science Corporation with the Antares launch vehicle, which the first flight is now scheduled for April 17th. It's only a couple of days from today. And we're building the engines for the first stage of that vehicle, so that's exciting. And Aerojet's really everywhere. They do a lot of things, and they have been in this business for a very long time. So that makes it a very interesting, exciting place to work, just because of the heritage that's behind it, but also because of the breadth of activities taking place.
Now, even though you've only been with the company for a short time, for the engines that you guys are developing for the Antares rocket, I believe it's the AJ-26s.
That's correct.
They are the reconverted NK-33 engines that the Russians had on their failed moon rocket.
Right.
Can you tell me a little bit about the process of what changes you guys might be taking place, without revealing any trade secrets, of
Sure.
what it's taking to be able to have those useful for the Antares?
Yeah, it's as you said, they're NK-33 engines developed and built in Russia. And we bought them a while back. Originally, they were slated for use in part on the Chrysler program, Chrysler Aerospace, which was another entrepreneurial startup that didn't quite make it. So we're now converting these, or refurbishing them, I should say, to become AJ-26 engines. And some of the major changes are obviously overhauling the engine. They're 40 years old, and they need some love and care to become flight-worthy again. And we also put a new gimbaling system on them to integrate it with the flight vehicle on Antares. And that's essentially it. So we have what we call an 11-step process. The engines are tested, refurbished. They're test fired at NASA Stennis for each one of the engines before they're certified for flight. And then we deliver them to Orbital for integration on the vehicle.
Nice. Now, I know that several months ago, it might have been before you started, there was a problem with one of the engines when they did a static test firing. And I'm not sure exactly the details of what the failure was, but I'm sure that's due to the age of the rockets. Is there any particular problems that you guys are having to completely rip out the plumbing and start from scratch?
No, it's not quite that bad. I mean, there are 40-year-old engines, and some of them have been stored in not what you would call ideal conditions for some of the time. So they're all a little bit different. It's kind of a salvaging operation in a car shop. You do restorations in a way. So we look at these engines at each case, for each engine specifically, and we go through this process of making sure that all the seals are still good. We replace some of the soft goods if they have decayed over time. And that's essentially it. So just testing each component and making sure they work and live up to the specs that are required for flight.
Interesting. Now, when Russia runs out of the Mk-33 supply that they have, are you guys going to be using the blueprints of the changes you made in manufacturing all new engines, just as the AJ-26, or will it be discontinued at that point?
The engine is certainly very capable. There are plans in Russia to possibly start production again, and there are also plans, the possibility of doing the same at Aerojet. We do have the rights to do so. However, it is a 40-year-old engine, and there are opportunities in other things, in other places where we could develop new engines from scratch as well. And I think if you look around, Aerojet has been kind of what people like to call the best kept secret in the industry. You know, we're everywhere, and we do propulsion on almost every flight vehicle has flown, but it's not very common knowledge, so it's not very obvious. But you look at the company right now, it went through some tough times about 10 years ago. It's restructuring, it's growing. There's a pending acquisition of Rocketdyne, Pratt & Whitney Rocketdyne of Aerojet right now. So when we combine the two companies, which will probably happen later this year, it will be a very large, if not the largest, rocket propulsion manufacturer in this country. And there are great opportunities in terms of combining the knowledge from the Mk-33s, the RD-180s, the RL-10, several programs at Aerojet currently too, in terms of NASA programs and Air Force programs developing new engines, to take all that technology, put it together, and come up with something improved that we can take forward.